Okay, so let's talk a little bit about lambdas. So lambda functions are sometimes called anonymous functions, which is a pretty accurate description of what they do, but it is a little bit misleading in terms of how they're implemented and how they work internally. So just kind of keep that in mind. I'll get back to that in a minute. But anyways, so the basic premise of lambdas is, let's say you have some small function and you're only using it in one place or, occasionally, and you might not want to go off and define this function somewhere else. That takes space somewhere else, that takes the time to, scroll up in your text editor. Maybe you want to define that function right there where you're using it. And in C++11, you have lambdas, which enable you to do this. Okay, so maybe you have a comparator, or maybe you have an argument to std for each, okay, where you want to define an operation to perform on each element in a container. C++11 with lambdas, this is very easy. Okay, so the syntax for a lambda is you have your capture list. Okay, so with your capture list, you define a list of variables that you'd like to capture. So those are variables from local scope, or surrounding scope basically, that you can then use in your function body. Okay, and then after the capture list, you have your parameter list, which is pretty self-explanatory. It's just the parameters that get passed to the function body, just like with a regular function. And then you have the optional return type part of the syntax. So if return type resolution fails, you can manually specify the return type here, but it's totally optional. In function body, that's where you define, or that's where you implement the function itself. Pretty self-explanatory. So down here you can see our example lambda. It's a very simple function. We're just returning 1, okay? So we have an empty capture list, we have an empty parameter list, and we're just simply returning 1. And then we invoke the lambda and pass its return value to cout. So it's just printing that return value 1 to the screen. Okay, so let's look at another example usage of a lambda function. Okay, so here we have a vector of ints, just 1, 2, 3 in a vector, and we're invoking std for each on the whole range of this vector. So we're passing std for each, a lambda, directly in the call to for each. Okay, so as a parameter, we have int ref. Okay, so that's getting a reference to an element in the container. And then in our lambda body, we're incrementing that element. So this has the effect of incrementing every element in that vector. So here you can see the equivalent code, okay, with a iterator-based for loop. And it's a little bit uglier, mainly because we have this long type name for the iterator. And we also have a dereference here before we increment, which looks kind of, it's not as appealing to the eye. So let's talk a little bit about the capture clause, and this is kind of a convoluted example, but it gets the point across. So the capture clause, like I said, it enables you to use variables from the surrounding scope within your lambda. Okay, and here's our example function. It's a templated function, increment list. It accepts a list ref as an argument, and it takes that list and invokes std for each. And for each gets a lambda. Okay, it captures this increments variable by reference. Okay, so this increments variable here we can use inside our lambda. Okay, and again we have a int ref parameter to that lambda. That is pretty much the type of the element. That's actually wrong. That should be tref, not int ref. So this will increment, this has the effect of incrementing each element in the list, assuming that type t has a pre-increment operator. So we're also incrementing this increments variable, okay, which has the effect of counting the number of increments that we perform. And so at the end we return that increments function, or that increments variable. So again, kind of a convoluted example, because you could theoretically just return the size of the list, but it does get the point across that you can that the capture clause enables you to use variables from the surrounding scope. So just a couple of words of wisdom before you start throwing lambdas everywhere. Lambdas are cool, okay? So you might be tempted to use them as often as you can, but they can be computationally expensive. And I'm getting back to what I mentioned earlier, okay, about how lambdas are actually implemented. So the way lambdas are implemented, a lambda, it's not really a function. It can be a function, but it's not necessarily a function. Okay, if you have a capture clause, then what you're actually doing is you're creating a lambda which becomes a functor object. Okay, so it actually becomes a structure. Okay, and that structure has member variables. Okay, and those member variables take on the value of the captured variables. Okay, and that's kind of the difference between captured variables and parameters. Parameters are the parameters to a function, basically. The operator, the function call operator of the functor object. But captured variables are member variables in terms of that structure. So in terms of computational efficiency, when you invoke a lambda without a capture clause, the compiler can kind of reduce it to just a regular function, okay? Because what you have is you have an implicit conversion to a function pointer, okay? So that your compiler can reduce it to just a function call. But when you have a lambda with a capture clause, it has to make that effort to construct the class object. So it's actually invoking a constructor there when you're calling your lambda. And then it has to set up those member variables, okay? And then only after that can it invoke the function call operator of the class. So it is computationally a little bit inefficient to have a lambda with a capture clause. So if a lambda really is suitable for what you're trying to do, try to avoid captures, because they do slow things down a little bit. And I say here, usually you can accomplish the same thing by, instead of capturing a variable from the surrounding scope, you just pass a reference as a parameter, okay? And that pretty much accomplishes the same thing in most scenarios.